Yeah, that could be a topic for another presentation. Okay, yeah, so I'm going to talk about microservices. I thought I might call it extreme SOA, but then I googled that. Apparently Oracle's already taken that. They're trying to sell you, you can do SOA on their Exadata platform, which sounds, yeah, really exciting. So maybe everyone should get involved in that. This mouse. Okay, yep, so like Saul said, my name's Braiden Judd. I work at REA as of Monday, so don't ask me any questions about REA. I used to work at Suncorp. I worked there for 7 years. And there's my Twitter handle. If you want to follow me, I use it a little bit. And I'll keep this in sync. This mouse is actually... okay, so what's your experience with microservices? This was going to be something I did, but there's not that many people. If you went to this URL, we could do this voting thing, but I don't think we'll bother. We can talk about it as a group later. Well, maybe we can do it by hands. Like, does anyone actually use microservices? Okay. Does anyone not even know what they are? Okay, that's half decent. So this might be a little bit redundant because this is like handhold through the 101 of microservices. But okay, how do we get rid of that?
CLO.
What is it?
It'll go away.
It'll go away if we. So I was going to define microservices, but I thought I'd just talk a little bit about core tenets. So if you don't do any of these, I think you'd find it hard to do any sort of microservices. So microservices is like SOA, but you really have to have your services being loosely coupled and highly cohesive. So this is where I think more back to your, if you've done uni, more about your uni days where you talked about object-oriented sort of stuff, and people told you had to have loosely coupled, highly cohesive classes. That's kind of what you want out of your services. So you want loosely coupled services so you can deploy them individually. When you deploy one service, it doesn't affect another service. Highly cohesive means, okay, so this billing service has got all my billing information in it. I don't have to, if I update the billing service, I don't have to update multiple services. A lot of the benefits come from, when you're talking about microservices, a lot of benefits come from services being small. Some of the risk involved, so people say, oh, you can have microservices written in all sorts of different languages. A lot of that risk goes away if you make them really small, because if you make them really small, you can rewrite them quickly. Developers can come in, comprehend the services quite quickly, and implement them in a different language and things like that. So I think microservices is in the name, small is quite important. The other thing, it's not really a core tenet, but it's really something you need to understand before you kind of delve into doing something like microservices, is team structure and how that team structure affects how you do services, how your architecture evolves. And I'll talk a bit about that. I've got a whole section for that. So I drew, I drew a little diagram in Google Docs. So this is probably actually a really bad version of microservices because I've kind of structured it around domains rather than event creating services. But what it really is services working together to create a better whole. So that's kind of SOA as well. So they're small, they're maybe 100 to 1,000 lines of code. I've heard a few variants of that. With modern day frameworks though, you can get a lot done with 100 lines of code, but that's probably on the smaller side. I've heard people say 100 lines of code is okay. You don't even need any tests because it's only 100 lines of code. If you need to test that, you're doing something wrong. Then I've heard 1,000 lines of code is okay. You could even do more. So it's really a bit arbitrary. But what I think microservices really is like what Saul was kind of saying, is it's kind of dragging SOA into the cloud world. So it's really, okay, deployments aren't painful anymore. We can do deployments unceremoniously. We can have Ansible, Chef, Puppet helping us along. So deployments aren't really a pain point anymore. So we don't have to do these big one day, every 3 months do this massive deployment. So that's where microservices has kind of taken SOA and taken it into the cloud world. The other thing to know about microservices is, while it affords autonomy within the services, so really you can maybe write whatever language, like the inventory could be written in Rust, payment in Elixir, shopping cart in some other exotic language, customer in Java or whatever. There are standards that you need to kind of think about in terms of the interfaces, the way you do deployment, monitoring and logging and that sort of thing. But it does afford autonomy in some places and freedoms in others. So I just wanted to show Netflix is one classic example of, I think Saul mentioned non-fragile architecture, I think they call it. And something like this here, top picks for Braiden. That's probably a service in the back end, and they say, you know, if that ever goes down, they might not show the line. So they do this thing where if the service is down, they might show some default data. They might show, okay, what are the popular movies in America at the moment? Or what are the popular, what are the newest releases that we have? Because they're probably going to be the top picks anyway. And then they keep working backwards from there until they have no data, and then they might remove it altogether. So it's about degrading the customer experience because we don't have a big monolithic app anymore. We've got a bunch of services. And if we've got a bunch of services and one goes down, we can kind of recover and keep moving on. So let's talk about the benefits. And one of the major benefits, like I've already said, is really the freedom and choice that microservices afford you. So while you might standardize interface between them, and you know, you might use HTTP between the services, you're allowed autonomy inside the services themselves. So you can write the services in whatever your kind of team feels like they can use the best, I guess. In the monolithic world, for example, if we wrote our app in Java, we had iteration 0, and we said, okay, we're going to write this big Java app that's going to do this big CRM system. And 3 months in, we decide Java's not the best choice. We really have no opportunity to change it because we'd have to spend 3 months rewriting it in whatever new language we wanted to do it in. And in those next 3 months, we wouldn't be delivering any value until we've rewritten the exact same functionality. With microservices, you can go, oh, okay, I'm going to try Elixir with this next service. Okay, that didn't work for us. Let's rewrite it back in something we're comfortable with and move on and treat it like a learning lesson rather than a failure. Another really good part about microservices is scaling. So there's two kind of parts to the scaling here. There's one, the obvious one is infrastructure scaling. So if you have a monolithic app and you want to scale it, you just put it on more boxes, you deploy the same app multiple times. With microservices, you can be a bit more fine-grained. You can go, okay, the customer service is running pretty hot, same with the inventory, we can scale those bits out, and we can leave the shopping cart as is, and maybe we can scale the payment down because we're not getting any payments at the moment. You can really adjust your infrastructure footprint to match the way your application is going, rather than, okay, we're just going to blob this monolithic out again and again and again. The other thing about microservices is the scalability of delivery. So if I'm part of a startup, for example, and I'm running a bunch of services to support my application, and I want to bring a bunch of new developers on because we've got some funding, for example. And if you wrote a big enterprise monolithic app, it would take them maybe weeks, maybe months to understand the app and start really adding value. Whereas in a microservices world, they might only have to understand one service to start adding value. So you can scale your employees up and down a bit better. Agility is kind of the same thing of what I've already been talking about. So you really have the agility to move around in terms of the payment gateway. Then a new payment technology might come out. You might want to use, I think it's called Square or something in the US. It's like a big payment service there. You might want to iterate on that on your product. You have the ability to iterate on the payment system without affecting the other parts of your system, because if they're real microservices, they're loosely coupled. It shouldn't matter as long as your interface stays the same to the other services. You can iterate on that, and you can move your developers from the other areas onto the payment gateway to implement that new technology. Resiliency is like what I talked about with about the Netflix model. If you've written your services really well, you've written them in a smart way, this one probably wouldn't work if you can't take payments. But maybe the shopping cart can say, okay, we've accepted your order, we'll process your payment when we're able to, or something like that. It can do a default behavior rather than in a monolithic world, if a part of your application went down, the whole thing goes down. In a microservices world, the ideal thing is to do something default, have some kind of default behavior so you can keep moving on so the customer gets a degraded experience rather than no experience at all. Geography is another thing that kind of, this. Geography is another thing. I drew this in Google Docs, but I think it's quite accurate. Yeah, geography is another thing that you kind of get out of microservices. So you can either fight the whole distributed agile. So I know of teams that I've worked in Suncorp and REA even, I've seen it, where we try and have teams across even different countries, different levels, different states and all that sort of stuff, and you fight this thing where we want to do distributed agile, we want to meet every day, do our stand-ups over VC and stuff like that. Whereas microservices, if you embrace that kind of distributed model of people, and you kind of have your service boundaries co-located within cities and things like that, you can really start benefiting from it by the high bandwidth communication within co-located teams, and then that low bandwidth between states or cities or even levels within the same building. And your kind of architecture drives out of the fact that you're not co-located and the fact that some people are co-located. So I wanted to talk a bit about now, so we've talked about what it is and the benefits. So now we talk about, so you can't just get everything for free. You don't get all that stuff without kind of sifting through some pain, some minefields and things like that. So the first thing I wanted to, when I talked before, I said there's some parts you need to, you're afforded autonomy, and some parts you really have to standardize because you can't just have total anarchy across the whole thing. So you really, there's a line here, so there's standardization where you can be safe and efficient, and this is great for manufacturing and things like that. They really want to be able to make 80 bonnets every day. They really want to, if they make 79, that's a bad day. If they make 81, that's a weird day. Like, how did they get an extra? They want something that's very safe, very predictable, very standard. Whereas startups, for example, they want something that's quite agile and empowering. They want to get customer feedback every day and pivot where they're going and that sort of thing. So there's certain places where you do want that standard, and there's certain places where you do want that autonomy. Otherwise, you'll have the microservices won't be able to benefit you as much. So, for example, in the interfaces between your services, you want to have that standardization. So here, that's where you normally talk about HTTP and things like that, because HTTP is supported by pretty much every language. It's a well-known standard. It runs the internet, which is like the biggest distributed system we've ever known. It's got built-in things like error handling, retries, caching, things like that. And then you allow freedom within the services. So you standardize the interfaces and the pipes and the connectors, and then you allow freedom within the services themselves. Another thing you need to kind of standardize is deployment. So kind of a consideration is you want to try and deploy quickly and often. So instead of, this is one example where you can deploy once and you get this big step up where you do this big monthly deployment. And then to step back down, so say if something went wrong, to step back down, it's quite difficult. But you could move to something like this, where you do smaller steps, so it's easier to step back down, easier to roll back. Because if in a microservices world where everyone's deploying at different times, everyone's deploying multiple times a day, you need to be able to step back if you've made an error, if you've deployed something bad. So, yeah, that's all about deployments. Integration testing is the next. Integration testing is the next thing you need to really consider. So you might be writing a ticketing system and you have a user of your service, and they might be the booking system. You want the booking system to write some tests so you can run those tests before you do your releases. And you know, as long as the booking team has written these tests and I run them before I do a release, I should be able to keep iterating on my service again and again and again. And also, likewise, the booking service might want to keep releasing their software even though they rely on my ticketing service. They don't actually want to keep calling your ticketing service as part of the development cycle. They'll probably want to write maybe a fake service against the ticketing service to kind of codify their understanding of your ticketing service. And then use that fake service as their test cases that they want the ticketing service to run. It's called consumer-driven testing, and it's something that you could probably have multiple talks. You could even have maybe 3 meetups in a row about consumer-driven contracts, because it is one of the hardest things to get right when you're dealing with microservices. Monitoring and logging is really important. So debugging these kind of services is quite challenging if you've got a distributed system instead of a monolith. If you've got a big monolith and it's acting badly, you can kind of, okay, you've got to investigate this one big blob. Here, you don't know which team or which service is responsible for the slowdown of your application. So you really need some really good standardized monitoring and alerting where you can really see requests coming in. So all these four microservices are logging to a central DB, but the request might come into the customer. They might make a request to the inventory service. They might do something to the shopping cart and make a payment. We need to see that request flow all the way through. So you need to do monitoring and monitoring for each of those services and log each request as it flows through your system, so you can really track how it's all working and find problems like that. You also want to log like status codes that are happening. So if you redeploy the customer service and it's doing more 500s than it usually does, or it's doing more 400s than it usually does, you want to know about that as soon as you do the deployment, not later. One of the last ones is automation. So it kind of goes without saying, if you're going to be doing deployments instead of once a month, you're going to be doing them 3 times a day. Your deployments need to be automated. So if you don't have automation in your deployments, if you can't, okay, the code's submitted to master in Git, and it's a manual process to get it into prod, you're probably not doing it well enough to be able to do these sort of daily or even hourly releases that you kind of need to do with microservices. Transactions is another thing to consider. So if you're running something like this and the customer purchased something, puts it in the shopping cart, and then goes to pay for it, and you've pulled it out of the inventory, and then only when the payment goes through, you actually really pull it out of the inventory, you've created a transaction, and what you've done is coupled the payment service with the inventory service and perhaps the shopping cart service. And creating coupling between these services is going to create you probably pain. So you want to avoid this sort of thing, and this is because I've kind of designed this 4-tier, 4-service application around domains. And domains sometimes aren't the best idea, because if you imagine a big database and you've got tables and the tables have relationships between them, you might find a database that has relationships between customer and inventory and payment. And because you've got those relationships, you're probably going to create these coupling and therefore transactions across services. And they're really hard to solve, so you probably want to avoid it at all costs. The last thing on considerations that I want to talk about was creating archetypes. So the fact that you have freedom to use different programming languages and for different services and things like that, and you want to have monitoring and alarming, and you want to have logging, and you want to have these standardized interfaces and all that sort of stuff, you really want to create these things like archetypes, so people can go, okay, I want to do a Ruby service. They can pull a basic Ruby service out of Git or whatever, and then start working on it as a base Ruby service. Creating archetypes and kind of blueprints is a pretty good idea. And that leads to the last part of organizational structure. So organizational structure is really, how does my organizational structure affect the architecture of my application? And if you've ever read anything about microservices, you'll come across this thing called Conway's Law. And reading it out, organizations which design systems are constrained to produce designs which are copies of communication structures within those organizations. It was written by a guy in the 1960s, but time and time again, people are saying that they try and do this sort of architecture, and if they don't have the team structure to match it, they're fighting a kind of a losing battle. They're fighting something like gravity. You're always going to lose. So the thing is, you really need to try and embrace this thing called Conway's Law. So you really need to think about more multifunctional teams that each are responsible for services. And it's back to that geography thing. You don't want to have teams crossing geography, location boundaries, because then you're going to have to try and get them to have a high bandwidth communication when it's really impossible, especially across time zones and things like that. So you really want to understand Conway's Law and then wield that kind of law rather than yield to that law. I listened to a really good podcast about this sort of thing, and the guy talked about codependence versus independence. Next slide. And he said that codependence is actually a bad thing between teams. You don't want teams to be dependent on each other, right? You don't want team C to have to do something for team A to do something else. In a microservices world, they want to be loosely coupled. They want to be have their own ability to evolve in their own way with their own priorities and that sort of thing. But within a team, codependence is quite healthy. You want the whole team to be there to do something useful. You want them to having retrospective stand-ups and things like that. And that requires a really high bandwidth communication. But inter-team, you want them to be independent. You want the teams to be able to evolve individually. And I've got a link to that podcast at the end, which I really recommend people listen to. So this might be a bad way to structure your team. So if you structure your teams with the UX designers, with middleware engineers, with DBAs, you're probably going to end up with the old school three-tier app, because people just fight, and the way they kind of tend to want to organize themselves, your architecture will tend to flow that way. because of the Conway's law thing I talked about. So you want to have teams more built around multifunctional teams, and then you can really, you have the freedom then to kind of just distribute them around. You can hire talent where you might be able to get talent, so maybe Melbourne's saturated for the people you want. So you have more freedom to hire people from different areas. And I mean, REA, what we do is we have a lot of people in China and things like that for the cheaper development there. And we give them different services than maybe what we've got onshore, and we use our onshore resources to do a bit more of the architecture, and we use over there to do more of the service development. So it's a better way to do distributed agile. So what are the takeaways? So it's really microservices. You want loosely coupled, highly cohesive services. You want them to be small, very small as you possibly can. As long as you're really good at deployments, you won't pay too much of a penalty there. You want to deploy quickly and often, so as soon as code is ready to deploy, you want to deploy it and start getting value from it. You don't want to keep waiting for releases to build up and do your monthly deploy. It's not going to help you. Know where to standardize, so you want to standardize on the deployments, logging and interfaces. And you also want to understand how your team structure can impact the way your architecture falls out. At the end of here, I've got a bunch of links here that I found quite useful. Some are conference talks. This one's really good. It's by, I forget his last name, it's Frank someone. He did a really good one in 2012, so it's a little bit old now, but it still applies. And there's a couple of podcasts here, one with a guy from REA that designs our mobile front end, and he did a really good one there. So, and that'll be it, I think. So.
Yeah. Are there any questions? Do you want to?
Oh yeah.
Your point about organising via events rather than domains.
Yep.
Could you elaborate on that a little bit? Why that's important?
Well, I haven't seen so much of it in real practice, because what we tried to do was via domains, and we actually got stuck where you're basically putting services over your database, and then you end up doing services per table and things like that, so you end up with a single source of truth. This is like a really naive way to do microservices. So we thought, oh, well, we'll just have multiple services talking to one data source. And then when we structured it by domain, invariably, you've done that with your database. You've gone, a table is a customer, and then you've got a table called inventory, and it relates in a certain way. And that relation is exactly a coupling. So in the end, you haven't really done microservices. All you've done is hosted your endpoints on different servers. So we found that a better idea is to use some sort of like a bus where services can create events, put it on a bus, and then other services are consumer of events and pull them off the bus, things like that. And I think that's where maybe if you start doing microservices a bit more advanced, in a bit more advanced way, you'll then start thinking of event-driven kind of services rather than trying to just abstract your database in different service endpoints.
So in that example, in reality, is the data still foreign keyed in the database the same way, but now you use an event bus?
Yeah, so I think more like payments is probably a good one. So payment might be one, customer registration might be a service, the sign-in might be a service. So they're like events people can do. And that kind of suits more into like the REST model.
Yeah.
So REST is kind of exposing APIs that marry up with the way users click through websites. And the users don't create a customer, they sign in, or they log in, or they create an account. And you want your service to be more around those sort of things instead of, you don't want to create it around things that technically might feel like they make sense. You want to do it around the way the application's used and events that are created in the application.
Yeah, I was just going to say, because one of the, I think, microservices you missed up there is something to handle your logging. Because my first microservice I wrote, which had no tests,
which is fine if it's really
which
small.
was purely for logging, because we had logging, and my architecture was suffering because of the logging to Splunk, and it was really suffering because Splunk couldn't consume it, so it was taking time to get those messages across. And so we introduced a service bus and a microservice to then deal the logging to Splunk to deal with the load, so it could go up and down. And we went from 32 servers down to 4. And even then, I think I'm over capacity. I'm just being a bit more paranoid. I know it's the only two very small services, single core services to handle the logging.
Yeah.
So we really cut down on our costs just by introducing a service bus and a microservice. And it wasn't something, it just didn't make sense at the time. So, you know, you sit there crashing and go, what's the problem? And then when we broke it all out, you know, you got a feel for what the problem was, but it just didn't make sense. Once we've broken it out, and that's what we've done, life is nice, more stable. The servers aren't sort of tripping over or scaling ad hoc without thing. Now, you know, we dropped it to 4 and it never scales. Whereas before it used to scale up between 16 and 32 throughout the day. And it was just to drive us potty, what the hell's going on here?
Yeah.
So I realised that it was all down to logging.
It's a really good point, yeah.
So
you can probably have a whole other thing talking about how to do logging properly.
yeah.
So yeah, there's some good, there's some talks by Udi Dahan. I think there's one, if you Google, it's called component-based services or something like that. Maybe I can put a link up in the discussion group, where he talks about this verticalization of microservices and the idea that the back end is self-contained within the service. So rather than having a common database where it ends up being a source of coupling between services, because even though they're all decoupled at the front end, at the endpoints, they all end up being coupled in the database. The idea with microservices is to take a vertical slice rather than traditional 3-tier architecture. There's a horizontal slice 3-tier architecture. Microservices is a vertical slice. So the endpoint, the middle logic, whatever that might be, and the database itself are all independent, completely different instances, if you like. And then you have the issue of, well, how do you coordinate between them? And that's done in a loosely coupled manner via this publishing of events. The events represent the state, and you share the state across the microservices using those events. So it's a really interesting area to get your head around.
Sorry, I thought you carried. I've had a question. You go first.
Sorry, I think both of you have just touched on this, but I just wanted to make it, see if you can make it explicit. When you say autonomy, and you've spoken about events and bus, would you say when you design a service and to do something useful, that service also needs to query out into another service? Or after it's done something, it needs to then go and tell someone else, so it sends an RPC call to someone else, right? Is that autonomy then when it needs to, it goes out to other people?
Oh, okay. By autonomy, I meant more around the teams that own it have autonomy to evolve the service how they want to, more of a cultural, like more of a team-based thing.
But would you design services in a way that they don't query onto? So Udi Dahan is very vocal about this, where he says,
Yes.
If you have designed services in a way that, for example, they go with their own database,
Yeah.
but if you find that the billing component, for example, is given a message to bill, if it goes, can I know the price of this, and it goes across to the sales catalog to say, can you please give me the prices? That's not autonomy, because if that goes down, the billing component is not able to fulfill its task.
I haven't actually seen that very much, because I can't imagine services being that useful if they couldn't rely on other services to do useful things. But I don't know if someone else has
I think that's a really interesting area that we can discuss in future. And my feeling is that the answer is it depends.
No, I think the way I was more curious, I obviously know how you've done it and what's your experiences.
Yeah.
But I think the way you promote it is, obviously, there's part of information that you own, which you change, which is building, it's your transactions and whatnot.
Yeah.
But pricing, which you don't own, you obviously can listen to the events. As and when prices change, you listen to those events, and via an event store, you either get the stream down or you listen to the events and you map down to your own model, so you have the prices there.
Yeah.
So when you're giving a billing message, because you've already had the events come through, you can look at, just like the real world, when the sales catalog is printed, a copy is given to the accountant, a copy is given to the guy at the front desk, so that when people come in, they don't call and say, hey, someone wants this, what's the price? They look it off the copy they have. So So I was curious if
So I think the traditional way of doing SOA is this layered SOA, and there is some discussion around the microservices world about layered SOA versus non-layering. And I think the argument with the layered SOA is that when you have high-level processor services, which are then calling function services, which are then calling entity services, then you end up getting lots of coupling between the layers, and that can be a bad thing. And I guess what they're trying to do with microservices is get some middle ground where there's certain, where you're not creating this spaghetti architecture of services on services. Now, Idi Dahan probably goes to the extreme where he says, I want that whole microservice to be standalone, and any call-outs should just be via events only. I think the reality is sort of somewhere in the
Yeah, I find it hard that like the orchestrator on top of that would be quite heavy, I would have thought.
But there is no orchestration, right? Because it's literally, it's either listening, so obviously you have a command at the boundary,
Yes.
where a customer is saying, I want to send this order. So a command comes in via the boundary, but once it comes in, it's all eventing from there on. So
Yeah.
there is no orchestration, there's choreography where they're listening to each other's
Yeah.
events and go, hey, an order's been placed, I'm interested in trying to reserve it. I've just reserved it. So billing could go,
Yeah, okay.
an order's been reserved, and it's been placed, and the customer's been approved. Looks like it's good to go, and I'll
The
do it.
risk is if your services become just transactional, they won't get micro, they'll end up being too large.
Yes.
Because you're
And
actually
that's-
trying to do a lot of things in the service.
Yeah. I will often talk about transactional if you know that more. I was going to quickly ask a question on whether you talk about microservices being either 1,000 lines or 100 lines. And this is one of the big things I think is slowing the adoption up where I work at the moment. Is people go, oh, but it only does like 100 lines. Why should I dedicate a couple of services of all the pipeline and all the infrastructure for this couple of lines? Can't I just stuff it in there? And I think that's the problem, is how, obviously you with Suncorp before you had to move to REA, so you probably won't be able to see how REA deal with that, but how did you deal with that at Suncorp?
Well, I think it's the whole, I think Docker helps a little bit because you can actually have Docker containers that boot up quite quickly. So small things that you don't have to have a server to run a service, you can have multiple servers running on a server.
Yeah.
So people get terrified about that whole infrastructure argument seems a bit void now with the cloud
Yeah.
and things like that. And then it's just an arbitrary number though, right? So it's really whatever makes sense for you. And I think that's what microservices is not. There's no like handbook. It's actually really great. It's a discussion that forms what your microservices are. So I think if you're getting bogged down in like 100 lines. If you're talking 100 lines or 1,000 lines, you're probably saying the wrong things, I guess. Because you're talking about lines of code when you really should be talking about what's the smallest thing that does something functional that is useful to me. And if people are worried about, I can't get a server small enough to host a service that small, I've used Docker a lot, and Docker really helps with that sort of stuff because you can run multiple things and you can really control within that VM, and you can boot them up really fast as well, rather than on a VM it takes minutes to boot up.
There's one talking about transactional just then. The ways I've dealt with that in the past is to deal with like compensation, if people have heard that term before. And in obviously event sourcing or whatever else, is that you just put new events on which actually actually doing reversals like in accountancy. So you take something off and then you just send up a reversal of that action again onto your queue and deal with it that way. So if something fails along the line, those that fail with it deal with that as a compensatory action, which is to do a reversal, which is to undo that action. So you can always still replay if you're doing event sourcing from beginning to end, or you could just be an action which just says, add one back into inventory, or that sell didn't happen, so we'll just put that block back or whatever else, and have all the tracing just to make sure you don't repeat yourself multiple times. So that's just the way I've dealt with that sort of issue in the past with transactions. Because you say transactions across multiple systems, it's just painful.
They just create brittleness.
You create a very expensive single-user system.
Yeah.
You actually can't have that if you don't have multiple systems and listing themselves in a distributed transaction, then you can't actually have them in a transaction even if you want to.
Yeah.
So you have to, like things where I've dealt in the past is the inventory system gets the order because it's been placed. This is the event, and it goes, okay, I've booked it. Billing goes to bill it. If it fails, then inventory listens to the fact that it's failed and goes, okay, I'm going to put that back into the pool.
Yeah, so that's
it's available. So that's a compensation action there. You go back.
So I guess you're probably all familiar with Gregor Hope's article about why Starbucks doesn't use transactions, and he likens that idea to when you buy a coffee at Starbucks, you don't all sort of
Yeah.
go like this, and you take the coffee and you give your money all in one transaction. It's done more as an evented process. And if something goes wrong, yes, then there's some compensation, like, well, they'll give you your money back, or they'll give you another coffee.
Yeah, that's a good term.
Yeah, that's all.
In fact, the ATMs do that. If you go to an ATM, if you withdraw cash, and if it says amount of cash and does something wrong, you'll actually find that if you were to look into your statement, it's actually withdrawn it,
Yes.
and then it'll put it back in. You won't find that nothing happened.
Yeah.
Yeah, but also accountancy practices again there, they like to trace that. And as Greg Young, when he came over and talked to me, talks about event sourcing, people talk about Greg Young, he talks a lot about that as well, and even goes back, I think, to like an early accounting system done on slate tablets. And it says, here's an event source, and it does that compensation sort of action. You know, here you go, I sold sheet X to person Y, oh no, didn't sell it, you know, big line through it. You know, and it's that sort of actions that happen.
I think, isn't that the Babylonians used
Babylonian
tablets, so they couldn't rub things out,
yes.
so they had to do compensation.
Yeah.
The original event sourcing.
You know, used to have accountants always used to do that as well with their books and whatever else. You know, everything was written in pen. You weren't allowed to use pencils and that sort of stuff. And that's again that same sort of tracing event sourcing. You can always start at the beginning and always get to the same point no matter what happens. So.
But what about the performance?
What for event sourcing?
Yes.
People worry about that. And yes, if you're always trying to read your event source from here, but there's nothing saying you can't take a particular state at a point in time and then build from there. So a bit like your transactions logs in the database. You know, you've got your database and you apply your transaction logs, and then if something fails, you can run those. When you do your log shipping, you can replay those transactions on another database and get to the same state. So you've got a view of state of now, and you can look after into the future a little. You know, you create new events and build up, and then you can take another snapshot, and then carry on from there. But you can still keep all the events from times if you ever want to start again with new code, new databases. You can do that as well.
So, how do you decide that which point that you want to take it on?
Take your pick, hour of the day. So, yeah, people choose whatever they like, whatever makes sense to them. So it's something that you learn as you start doing it. You know, some people just start, I'll take a snapshot every day and work from there. And some people just, because most of the time you have view models anyway, running off your event source, and they're the ones that, you're building from your event model. And they sort of build up over time, and then, you can throw them away and build them, rebuild them again if you want to. So you tend to have lots of views on your event which you can just throw away. That's different to microservices, but it is a concept that can be very useful in microservices, especially for keeping your databases with your microservice and keeping that succinct one there. As the man over there was saying about listening to events, and then you build those event models from that event source. So it's very powerful.
Yeah, there's some good knowledge around the CQRS pattern, around using events to record the activities within your system, and then taking views of that into the read views, so that you're then deriving the current state of your system from those events, and you're either taking snapshots or views or whatever.
Yeah.
I think the other thing with the performance questions is, so I've been reading Sam Newman's book about microservices, and he talks about just publish events, even if you don't think you need them, just publish lots of things, because then that gives you, I call it serendipity. You get things that you can use and discover and make use of. There's an open source project called Kafka that came from LinkedIn, I think, I'm not sure. But if you Google Kafka, you'll find it. And they talk about, so it's an event sourcing product, and basically you fire events out into this message stream, event stream, and they persisted all along the way. It's got some really nice persistence, and you can subscribe to a Kafka stream at any point in time. You'll get all the past events. And there's a long blog article about it and its architecture, and they say, this whole thing about performance and disk I/O and all of that thing is a bit of a furphy, because the way they basically persist into files always appending to files, not backing up and not doing kind of arbitrary accesses to the files. Because they're always appending, it's pretty fast. And
It's all sequential, not
yeah, exactly. It's all sequential. So it ends up being not that much of a performance overhead. So, yeah.
Yeah, and you also get people like to use their NoSQL databases as well. So you're building up your models independently, you're not dealing with SQL, and so I found people like to do that as well. So.
Yep. All right. Okay. Anything else? All right. I'll start up mine. If you want to jump up.